The golden age of arcade games brought us classics that tested our reflexes and strategies. Among them stands Breakout, a symbol of both simplicity and challenge. Today, we're diving deep into the mechanics of recreating the Breakout game. But why Breakout? Beyond its nostalgic charm, this game is simple yet intricate, making it the perfect use case to understand game mechanics, physics, and user interactions. Our choice of language? Python, known for its clarity and versatility. And to bring our game to life, we've chosen the Pygame library. The architecture we've adopted is object-oriented. It modularizes our game into distinct components like the paddle, ball, and bricks. With the stage set, let's embark on this journey, line by line. In the first few lines, we begin by importing the necessary modules, Pygame, sys, and random. These modules will enable us to build the game's graphical interface and handle essential functionalities. Next, we define three classes: paddle, brick, and ball. These classes represent the paddle, bricks, and ball in the game, respectively. Each class has its constructor in it and other methods to manage drawing, movement, and collisions. Let's dive into each class line. The paddle class represents the player-controlled paddle in the game. It allows the player to move the paddle horizontally using the left and right arrow keys. In the first line, we define the paddle class, which will handle the behavior of the paddle in the game. The init method is the constructor for the paddle class, which initializes the paddle's position and size on the screen. Within the constructor, we create a Pygame rect object to represent the paddle's rectangular shape. It is positioned at the given x and y coordinates and has a width of 80 pixels and a height of 10 pixels. The draw method is responsible for drawing the paddle on the game screen. We use the Pygame draw.rect function to draw a white rectangle representing the paddle using its self.rect attribute. Moving on, the move method enables the paddle to move left or right based on user input. It checks for the left and right arrow keys being pressed and updates the paddle's position accordingly. Now, let's explore the brick class. The brick class represents the bricks that the ball must break to score points in the game. We start by defining the brick class, which handles the behavior of individual bricks in the game. The init method serves as the constructor for the brick class. It initializes the brick's position and size on the screen, as well as randomly assigns a color to each brick. Within the constructor, we store the x and y coordinates of the brick in x and y instance variables, respectively. We also create a Pygame rect object to represent the rectangular shape of the brick. It is positioned at x, y, with a width of 60 pixels and a height of 20 pixels. To add some visual variety to the game, we generate a random RGB color using random randint function and store it in the color instance variable for each brick. The draw method is responsible for drawing the brick on the game screen. It uses Pygame draw.rect to draw a rectangle representing the brick using its position and color. Finally, let's examine the ball class. The ball class represents the ball in the game that bounces off walls, the paddle, and breaks the bricks. We define the ball class, which handles the movement and behavior of the ball in the game. The init method is the constructor for the ball class. It initializes the ball's initial position on the screen. Within the constructor, we store the initial x and y coordinates of the ball in start_x and start_y instance variables, respectively. Afterward, we call the reset method to set the ball to its initial position and give it an initial velocity. The reset method resets the ball to its initial position and velocity whenever needed. It creates a Pygame rect object to represent the ball's rectangular shape, sets its initial position, and gives it a horizontal velocity, dx, of 1 and a vertical velocity, di, of -1, which means the ball initially moves right and upwards. The draw method is responsible for drawing the ball on the game screen. It uses Pygame draw.rect to draw a white rectangle representing the ball using its position. The move method moves the ball based on its current velocity and speed. It updates the ball's position using the move_it method of Pygame rect. Lastly, the bounce method handles collisions between the ball, the walls, the paddle, and the bricks. It reverses the ball's velocity when it collides with walls or the paddle and returns the index of the brick that was hit if it collides with a brick. The Breakout game class is central to our game's architecture. The init method sets up the game environment, including the display, paddle, ball, and bricks. The reset_bricks method arranges a fresh set of bricks on screen. The draw_text method facilitates on-screen text rendering. Now, we reach the heart of the game, the main game loop. This loop runs continuously and handles the game's events, updates, and rendering. We check for any events, such as the user closing the game window, using the Pygame event.get method. The paddle is moved based on the user's keyboard input using the move method of the paddle class. The ball is also moved using the move method of the ball class. We then check for collisions between the ball, the paddle, and the bricks using the bounce method of the ball class. If the ball collides with a brick, we remove that brick from the array, and the player's score is updated. Next, we check if the ball reaches the bottom of the screen, indicating that the player missed it. In this case, the player loses a life, and the game may reset if lives are exhausted. If the player hits all the bricks, the ball stops, and a congratulatory message is displayed, asking the player to press any key to start a new game. The run_game method is the primary game loop, orchestrating the game's flow. Within run_game, we handle paddle movement, win conditions, ball movements, ball bouncing mechanisms, scoring, and game over scenarios when the ball misses the paddle. Lastly, our entry point ensures that the breakout game is initialized and executed only if this script is run directly, not when imported elsewhere. This code showcases a structured approach to game development using Python's object-oriented principles. By understanding each component, developers can further optimize, refactor, or extend the game's capabilities. Thank you for joining this in-depth walkthrough. For more insights into software development, be sure to subscribe and stay tuned. Questions and discussions are welcome in the comments section.